Hi, I'm Fei. In this project, I worked with the ABC Bank dataset to modernize their credit card approval process. So currently, the manual review process is slow and prone to bias. My goal was to build a machine learning pipeline that automates approvals, reducing operational cost while maintaining high accuracy. The target variable here is binary 1 for approved and 0 for denied. The first, data quality is the foundation of any ML model. I started by using the AutoVis for exploratory data analysis to spot outliers and distribution issues. Data cleaning. I handled missing values and addressed high cardinality in categorical feature like age. Encoding. For categorical variables, I applied one-hot encoding to convert them into a numerical format suitable for the algorithms. Scaling. Since I plan to use the logistic regression and the PCA, I standardized the data using standard scalar to ensure features with large ranges, like total income, didn't dominate the objective function. Balancing. Credit data is often imbalanced, so I utilized SMOTE to create synthetic samples of the minority class, ensuring the model doesn't just predict denied for everyone. So to capture complex patterns, I specifically engineered new features, and I used the k-means clustering to group similar applicants and added the cluster ID as a new feature. I also applied PCA to reduce dimensionality, which helped remove noise and the multicolorality before feeding the data into the models. I selected the three distinct modeling approaches to solve the binary classification problem. The first is the logistic regression. I use this as my baseline. It's highly interpretable, which is critical in banking regulations, and we need to explain why a loan was denied. And the second one is the random forest classifier. This ensemble method captures nonlinear relationships between features like age versus income better than linear models and is robust against overfitting. And the third is H2O AutoML. Finally, I leverage H2O's automated machine learning to test a wide variety of algorithms to find the absolute best performance benchmark without manual tuning. The results show that both logistic regression and random forest achieve a high accuracy, mainly by predicting the majority class, while clustering provides no real improvement, and the models perform very poorly at detecting the minority class. So comparing the result, here's what I found. I focused on recall and AUC stands for area under the curve. In credit approval, a false negative is a loss opportunity, but a false positive is a financial loss. The model named GBM/5 performed the best with an AUG of roughly like 0.5729. It provided the best balance between catching bad applicants and approving good ones. So in conclusion, automated ML models can significantly outperform manual reviews. Feature engineering steps like SMOTE and clustering were decisive factors in model stability. However, techniques like the PCA make the model harder to interpret. In order to improve this further, I would perform a more aggressive feature selection using like REF, recursive feature elimination, to remove noise and tune the hyperparameters of the random forest model more deeply using the grant search. So implementing this would allow ABC Bank to give instant decisions to 80% of applicants, leaving only the borderline cases for human review. Thank you, and thank you for your time.